Hello friends, in this video we'll discuss about important algebra formulas which includes basically equations, inequalities, compound interest formula. Let us start with equations. We are considering that A, B, C, P, Q, U, V and X are the positive real number and x1, x2, y1, y2 and y3 are the solution of the equations. So we have 59th number formula, that is linear equation in one variable ax plus b equals to 0. Then we have x equals to minus b upon a. 60th number formula quadratic equation, that is ax square plus bx plus c equals to 0. So we have two roots, that is given by Sridharacharya formula, that is given by minus b square plus minus under root b square minus 4ac upon 2a. Next is we have discriminant, that is represented by d, and we have discriminant b square minus 4ac. So according to the discriminator we decide the roots will be real, different or imaginary. If discriminator is greater than 0, roots will be real and different. If discriminator is 0, roots will real and equal. If discriminator is less than 0, roots will imaginary and different. Next is 62th formula, weightage formula, sum and product of roots. Let if we have x square plus px plus q equals to 0, then x1 plus x2 sum of roots equals to minus p, and if we have x1 and x2 the roots of the equation, then x1 into x2 equals to q. It is similar to the equation ax square plus bx equals to 0, then x1 equals to 0 and second root minus b upon a. Next we have a x square plus c equals to 0, so roots will be plus minus under root minus c upon a. Cubic equation or Cardano's formula for the third order equation, y cube plus py plus q equals to 0, then we have y1 equals to u plus v, and another roots are minus 1 upon 2 u plus v plus minus root 3 by 2 u plus v into I, where u equals to cube root minus q by 2 plus under root q by 2 का whole square plus p by 2 whole square, and we have v equals to cube root minus q by 2 minus under root q by 2 whole square plus p by 2 whole square. Next is inequalities. Inequalities we have variables x, y, z, and we have real number a, b, c, mn and a1, a2 up to an. We have four discriminants d1, dx, dy and dz, inequalities and interval and their graph respectively. First inequality is, let we have x is greater than equals to a and less than and equals to b, then interval will be a included, b also included. So we have graph a included up to b and b included. Next is a is less than x and x is less than and equals to b. A will be excluded but b will be included. A excluded, graph goes up to b but b is included. Next is when x is greater than a and equals to a but less than b, then we have a is included and b is excluded, and graph will be shown as here. So next is a is less than x and x is less than b, then both are excluded and graph will be shown as here. Next equality is similarly shown from minus infinity is great less than minus x and x is less than or equals to b, where x is less than equals to b, then we have interval from minus infinity excluded and up to b. Similarly, for we have this one, that is minus infinity to b, both are excluded. Next is for a is in, included up to the infinity, and next finally x is greater than a and x is less than infinite, then we have a is excluded, infinity is excluded, and the graph is shown here. Next we have if a is greater than b, then b is less than a. If a is greater than b, then a minus b is greater than 0, or b minus a is less than 0. If a is greater than b, then a plus b is greater than b plus c. If a is greater than b, then a minus c is greater than b minus c. If a is greater than b and c is greater than d, then we have a plus c is greater than b plus d. If a is greater than b and c is greater than d, then a minus d is greater than b minus c. If a is greater than b and m is greater than 0, then we have ma is greater than mb. If a is greater than b and m is greater than 0, then we have a by m is greater than b by m. If a is greater than b and m is less than 0, then we have ma is less than mb. Next formula number 76 is if a is greater than b and m is less than 0, then a upon m is less than b upon m. If a is less than 0 and a is less than b and n is greater than 0, then we have a to the power n less than b to the power n. Similarly, for we have when n is less than 0, then a to the power n is greater than a to b to the power n. Similarly, we have for a to the power 1 upon n is less than b to the power 1 upon n, and a to the power 1 upon a to the power 1 upon 2 is less than equals to a plus b by 2, where a and b both are greater than 0, and equality is valid only if a equals to b. If a plus 1 by a is greater than or equals to 2, where a is greater than 0, and equality takes place only at a equals to 0. Similarly, we have a1, a2 up to a n power 1 upon n is less than equals to a1 plus a2 plus up to a n upon n, where a1, a2, a2 are greater than 0. If a1 plus b is greater than 0 and a is greater than 0, then we have x is greater than minus b upon a. If ax plus b is greater than 0 and less than 0, then x is less than minus b upon a. We have second order equation ax square plus bx plus c is greater than 0. Then we have graphs according to the discriminator we as shown. We are considering two cases here when a is greater than 0 and a is less than 0. And first, when d discriminator is greater than 0, roots will be real and different and shown by this curve. When a is less than 0, curves will be again real, but the graph will be inverted as shown here. When d equals to 0, both roots will be equal and real, and when a is less than 0, graph will be inverted. When d is less than 0, the parabola is not cutting the x-axis, hence the roots will be imaginary, and similarly in this case there is no root exists and graph is hyperbola is inverted. Next is mo a plus b mod is less than equals to mod a plus mod b. If mod x is less than a, then minus a is greater than minus a is less than x, and x is less than a where a is greater than b. If x mod is greater than a, then x less than minus a, and x is greater than a where a is greater than 0. If x square less than a, then we have mod x is less than under root a where a is greater than 0. If x square is greater than a, then mod of x is greater than root a where a greater than 0. Similarly, if fx upon gx is greater than 0, then fx gx is greater than 0 provided that gx is not equals to 0. Similarly, when if fx upon gx is less than 0, then fx gx is less than 0. It is provided that gx is not equals to 0. Finally, we have compound interest formula that is very important. Future value we are taking here A, initial deposit rate is C, annual interest rate R, number of years invested is T, means total time period, and number of time compounded per year. General compound interest formula A equals to C bracket 1 plus R by n to the power n into T. 94th formula, simplified compound interest formula. If interest is compounded once per year, then we have A equals to C 1 plus R to the power T. Continuous compound interest formula. If interest is compound continually n will equals to infinity, then we have A equals to C e to the power R into T. Simple interest SI, principal amount into time into annual rate of interest upon 100 PTR upon 100. When interest is compounded half yearly, amount will be total amount after certain years P bracket 1 plus R upon 200 to the power 2T. When interest is compounded quarterly, amount P equals to 1 plus R upon 400 to the power 4T. When rate of interest is R1, R2, R3, then amount P 1 plus P1 upon 100 plus into 1 plus R2 upon 100 into 1 plus R3 upon 100. And finally 600th number formula, that is compound interest for 3 year 3R plus 3R square upon 100 plus R cube upon 100 square percentage of total capital. Thank you friends. Please subscribe our channel, like our videos, share our videos and comment to our channel. Thank you friends for watching our video.